Okay, looking into functions and inequalities. And let's say if we have a quadratic function, f of x is equal to x squared plus 4x, and we want to determine the solution set to 4 different inequalities that we have in comparison to 0. So we have x squared plus 4x is less than 0, x squared plus 4x is greater than or equal to 0, then we have third, x squared plus 4x is greater than 0, and then finally we have x squared plus 4x is greater than or equal to 0. So we have, starting off, okay, so we have f of x is equal to x squared plus 4x, and what we want to do is establish the zeros of what we have from this function. So if I set this function, x squared plus 4x equal to 0, now we have a factorable quadratic expression, and we have the greatest common factor is x, and we have, upon factoring out x, we have x times the quantity of x plus 4 is equal to 0, and looking at setting each factor to 0. So I have x equal to 0, and for x plus 4 equal to 0, okay, we have that x is equal to negative 4. So we have, for the zeros of f of x, okay, again we have 0 and negative 4. Now, in looking at establishing a table of intervals, and we have, just starting off, okay, so we'll be working around, okay, the zeros that we have here, starting off, okay, from negative infinity. Now I'm going to go from negative to positive infinity, and taking what we have now. Okay, so I'm going to go from negative infinity to the smallest or the smaller of the zeros, and between 0 and negative 4. Negative 4 is the smaller of the zeros, so I have going from negative infinity to negative 4. And then we have those values of x between negative 4 and 0, and for what we have next in line, okay, we have those values of x, okay, that will be greater than 0. Okay. And so in taking what we have now, I'm just going to go ahead and set up a table. All right. And I'm going to test each subinterval section, and we have in the process, okay, so just setting up, okay, what we have now. Okay, and we'll do, okay, is that for the representation of what I have for each of the subintervals, okay, that we have in place. All right, we're going to inscribe test values for the inputs. Okay, so we have with the test value x. Okay, so for testing out the first section, okay, so we have in this one, okay, we have the input at negative 5. You can select any value that's less than negative 4. Negative 10 would do the job, negative 19 would do the job, but negative 5, I want to get the absolute value as low as possible. And we have for the values between negative 4 and 0, okay, I can go with negative 3 or negative 2 or negative 1. I'll just go with negative 1. And then we have any value greater than 0, okay, I'll just go ahead and select positive 1. And taking what we have now, okay, so we're looking at, once again, applying the function. So we have the f of x is equal to x squared plus 4x, okay, and testing out any value x that we select that is less than negative 4, using negative 5 as a sample. So we have for f of negative 5, if x is negative 5, well, the output, you have the square of negative 5, which is going to be at 25. 4 times negative 5 is negative 20, and 25 minus 20, that's going to be a positive 5. Now to test out the next interval section, okay, plugging in negative 1 for x, negative 1 squared is going to be positive 1. 4 times negative 1 is negative 4. 1 minus 4 comes out to negative 3. Now for f of 1, have 1 squared is 1, 4 times 1 is 4, 1 plus 4 is 5. And so we have, for the next phase, okay, this is going to be primary pathway created for the solution of the inequalities. Now we have with the sign of f of x. Okay, so what's going to happen here is that anything we plug in for x that is less than -4, the output is going to be positive. Anything we plug in that is greater than -4 but less than 0, the output is going to be negative. So we have the f of x is less than 0. And anything we select for x that is greater than 0, the output is going to be positive. So we have the f of x is greater than 0. All right. So we have for our solutions. And if we go back and let's say that we have, first of all, okay, whereupon x squared plus 4x is less than 0. Okay, now this will be in reference to where we have f of x is less than 0, and we have for the solution, and where we have f of x to be less than 0, it'll be this particular subinterval of values x. So it'll be those values of x greater than -4 and less than 0. Now if I have x squared plus 4x is less than or equal to 0, now we're on the same direction as f of x is less than 0, and we still had the same numerical limits. And since the inequality has an equal sign, and since both -4 and 0 make this expression equal to 0, we're going to have both -4 and 0 in brackets. Now, on the side of what we have for x squared plus 4x is greater than 0, so you'll be looking at the set of values x such that f of x is greater than 0. And so we're going to have, in this case, we have for the solution set where f of x is greater than 0, we have those values of x less than -4. So we have from -infinity approaching -4. And we have also those values of x that will be greater than 0. And we have closing out. Okay, we have for x squared plus 4x is greater than or equal to 0. Again, so we're still applying nearly identical limits. But the difference is going to be the grouping symbols. Now, infinities are boundless. So you have -infinity in the parenthesis, and we got -4. -4 makes the statement equal to 0, and since the inequality has the equal sign, -4 is going to be in the bracket. And then we have with 0, like -4, that is also going to be in the bracket. And we have proceeding. We have going all the way out to infinity. Okay, and so those will be your solutions to the respective inequalities that we have regarding the function f of x is equal to x squared plus 4x.